Hi guys and welcome to this new tutorial. So, quick reminder, in the previous one we said that we need two extra pillars to transform our general blockchain into a cryptocurrency. The first pillar was to add the transactions in our blockchain class, which is exactly what we did here with this add transaction method, and also we added the transactions in our create block method, and we made that separate list of transactions which contains the transactions before they're added to a block. So we tackled this first pillar in the previous tutorial, and now in today's tutorial and in the next one, we will tackle the second pillar, which will be to include the consensus in our blockchain implementation. What is the consensus? That is just an algorithm to make sure that all the nodes contain the same chain at any time t. So whenever a new block is mined on any node, to welcome some new transactions that happen around that node, well, we will make sure that all the other nodes in the decentralized network are also updated with the same chain. And that's very important when we implement a blockchain, because indeed that's one of the pillars of the blockchain, that's one of the fundamental principles of a blockchain. So let's do this, and we might do this in two tutorials because I don't want it to be too overwhelming. We have a big function to make to implement that consensus. And before we implement the real consensus itself, well, we're going to add the node in the init method because indeed we'll need to consider the node to implement that consensus. And we will need to make a method which we'll call add node. And as the name suggests, this method will take as argument the address of a node, like this http://127.0.0.01 and then colon port 5000. So it will take this address and it will add the node containing that address in the network. So what we'll need to do in this first tutorial before we implement the huge consensus function is to first create a new variable here in this init method, which will be our nodes. So I'm adding self here, and then dot, and then our node, which will not be a list because there's not an order of these nodes. They're supposed to be all around the world, and therefore they're not supposed to have a certain order. And besides, for computational purposes, it's better to initialize them as an empty set as opposed to an empty list. And that's exactly how you initialize an empty set with this set function. So basically our nodes will be in a set, like a mathematical set, and now we will make this add node method to add any new node in this set by taking the address of this node. So far, and actually in module 1, we've seen one address example of a node that was, if we go back to the Flask quick start guide, exactly this address. That's one address of one node. But we will actually create some other addresses which will also start with this URL 127.0.0.1, but then we will add some other ports like port 5001 or port 5002, as many ports as nodes you want to add. So basically this will be the main root, and these numbers here, 5000, 5001, 5002 up to whatever 5000 you want, will be the different ports for these different nodes in our network. All right, so that's the address we will input as argument of this add node method we're about to implement, and this add node method will take that address and add the node to this set of nodes. All right, so let's do this. Let's add this method and we will create it right after the add transaction method. So let's do this. Def, then I'm going to call this method add node. And then as we said, this method is going to take, well, two arguments because of course it's going to take first self, since we'll be using one variable of our class, of our blockchain class, which as you might guess will be the nodes variable we just created 30 seconds ago. So that's what this self will be for. And now the other variable, as we said, is the address of the node. All right. So it will take the address of the node, and now what we want this method to do is to add the node containing that address to our set of nodes. So how are we going to do that? Well, we'll do that in two steps. The first step will be to parse the address of the node thanks to the URL parse function which we just imported right here. So we're going to use this URL parse function to parse the address of the node. Don't worry, for those of you who don't know what parse means, I'm going to show you what this means in the console. And we import this function from this urllib library and then from the parse module. So let's do this. Let's go back to our add node method and let's parse the address of the node. So since this URL parse function will actually return the parsed address of the node, I'm going to introduce here a new variable which will be parsed URL. All right, and now we're going to use this function URL parse, and this function is going to take, of course, the address of the node. Okay, URL parse address. Now we have our parsed URL. Perfect. And now we are ready to add this node to the network by taking our set of nodes, which we called self.nodes. So this is our set of nodes. And now we want to use something similar to the append function to basically add this node to our set of nodes. However, remember, nodes is not a list, so we cannot use the append function because append is only used for lists, but instead we have simply the add method in which you have to input what you want to add. That is not exactly the parsed URL of the address, but the parsed URL.netlock. And now, no worries, I'm going to show you right now what all this means. So what I'm going to do is first import this URL parse function by just selecting this line and then pressing Command or Control plus Enter to execute it. So as you can see in the console, I have my URL parse function imported. All right, so that's the first thing done. And now I'm going to create an address for a node as an example, and this address will be simply the address we've already used, that is the URL of the node on port 5000. So I'm copying this, I'm going back to Python, and here I'm going to create an example of this address argument, which will be the following: address equals, in quote, because the URL has to be input in quote, and inside this quote I'm pasting what I've just copied in the Flask quick start guide, that is the address of the node on port 5000. So since I just typed this in the console, I just need to press enter. All right, so now the address variable is created. Just pretend it's going to be the argument of this add node function we'll be using soon when we really add the nodes in our network. And so now what I'm going to do is show you what these two lines will do. So first, I'm going to take this, either execute this directly or copy this, then paste it in the console, and then just press enter to create this variable, and then I can just type this parsed URL to see what it looks like. So enter, and here is the result of this parsed URL. So this is what parsed URL contains. This is what parsing a URL means. You know, you get the scheme, which is HTTP, and then you get the netlock, as we already introduced here. You get the netlock, which is the URL, including the port 5000. And this is exactly what we want to get when we want to add our node into our set of nodes. We want to get the netlock, that is the URL, including the port. And that is why when I execute this, or again, just copy it and paste it here and just press enter, well, what I get exactly is this URL, including the port. Basically, we just get this part with the 5000. And that's enough to identify our node, because that's like a unique identifier of our node, and that is enough to add in the set of nodes. All right, so not too overwhelming when we have a look at it in details in the console. So we now have this add node method to add a node in our set of nodes. That's perfect. That's the first step. And now the next step is, of course, to implement this consensus, which we'll do through a big function that we'll call replace chain, because basically what this function will do is it will look at all the nodes in our decentralized network, it will check the chain of each of these nodes, then it will spot the longest chain, and basically in any node that contains a chain that is shorter than the longest chain, it will replace that chain by the longest one.